We will be discussing in this about the Ricart-Agrawala algorithm. This Ricart-Agrawala algorithm is an optimization technique which is implemented on the Lampport's algorithm, and it tries to dispense the release messages very effectively, efficiently by merging it with the reply message. So the working of the Ricart-Agrawala algorithm is the first point is whenever any site wants to request for the critical section, what it has to do. Suppose there are many sites and SI site is sending a request. So whenever a site SI wants to enter into its critical section, it will send a timestamp request message to all the sites in its request set. So it means whenever a site wants to go into the critical section, it will send a timestamp request message to all the sites. Now, when this the other sites receives the request, suppose the site SJ. So when the site SJ receives the request message from the site SI, it will send the reply message to the site SI if, depending upon the condition. And what are those conditions? If the site SJ is neither requesting or nor executing the critical section. If it is neither in the requesting mode or nor it is executing the critical section, or if the site SJ is requesting and SJ's request timestamp is smaller than the SI site's timestamp, SI requests timestamp is smaller than the SJ's own request timestamp. Otherwise, the request will be deferred. So meaning thereby, whenever a particular site is going to receive a request message, it will send reply if and only if the site who has to send the reply is neither in the requesting mode nor it is executing its critical section. The second point is if SJ means the other site is requesting critical section, but the site which has asked, which has sent their request message, that site's timestamp is smaller than the site which has to give the reply. By the timestamp is less, then only the SJ will be giving the reply message to SI. Otherwise, if both the conditions are not true, because for a particular case, both the condition has to be true. So otherwise, the request will be deferred. It will be put into the queue. Now, whenever a site is going to receive the reply message from all the sites with the timestamp, whatever they have sent, if it has received the reply message from all the sites in its request set, then it will go into its critical section. Suppose the requesting site was SI. SI will enter into its critical section only after it has received the reply message from all those sites in its request set. Suppose P1 has sent the request message to P2 and P3. So it will be in its request set that it has sent a request message to P2 and P3. So until unless P2 and P3 is not going to give reply, and whenever it receives the reply from P2 and P3, it will go into its critical section. Now, how it will release its critical section? So I have taken an example of SI site, which is requesting in the requesting mode, and the SJ site, which are in the receiving mode. So when a site SI exits, and since SI has received the reply message from all those sites, so and it has entered into the critical section, and when it wants to exit, so suppose SI is the site, so when SI exits from its critical section, it will send the reply message to all deferred requests. जितने भी request defer किए गए होंगे, that will be given the reply from that site SI because SI at that particular moment of time was in critical section whenever it might have received any request message from the other side. So until unless, so while exiting from the critical section, then only it will be sending the reply message to all the deferred requests. How it will be able to know about the deferred request? Because the other sites might have given the request message, and whenever they have given the request message and reply message is not given by that particular site, so it will be in the queue and it will be stored in the request set of that particular site. Now, a particular site's reply message will be blocked, or it is blocked only by the sites that are requesting the critical section with the higher priority. And whenever we talk about the higher priority, means the smaller timestamp. Suppose when SI was in critical section, and at the meantime S2 and S2 and S3 has given the request, other sites has given the request message to the site SI which was in the critical section. So the timestamp out of these two sites, the jiska timestamp kam hoga, that will receive the reply first. So it means when a site sends out the reply message to all the deferred requests, the site with the next higher priority request which has received the last needed reply message, and it will go into the critical section. So the execution of the critical section request is always in the order of their timestamp as far as the Ricart-Agrawala algorithm is concerned. Now, as performance is concerned, there are only two messages. One is 2n-1 because one is the request and another is the reply. And the synchronization delay is the time. Now, whenever we talk about the optimization of this Ricart-Agrawala algorithm, as Ricart-Agrawala algorithm is an optimization of the Lampport's algorithm. So the Carvalho has given the optimization solution, and it has proposed an improvement in the Ricart-Agrawala algorithm by observing that once a site SI has received a reply message, once a site has received the reply message from the site SJ, this kind of authorization implicit in this message remains valid until SI sends a reply message to SJ. And this happens when this happens, which happens only when the request message is received from the SJ. Otherwise, it will not. So what is the meaning of that? Therefore, after the site SI has received a reply message from SJ, SI can enter into its critical section, any number of times without requesting the permission from SJ until SI sends the reply message to the SJ. Meaning thereby that SI, once it gives the reply message, it means it is coming out of its critical section, and it will give the reply message to the other side who has requested. Those who have not requested will not send the reply message. So once the reply message is given, since SI has executed its, since SI was in position of executing its critical section, so as number of times it is required to execute its critical section, it has not to send any further request. It has not to take any permission for in the form of a request from the other side. So as many as critical section it wants, it can execute. But once it will give the reply message, it will be out of its critical section. So let us go for, with the example of that. Suppose in this example, what has been shown that in step number 1 there are 3 sites S1, S2, and S3. S1 is sending a request message to other sites. S2 is also sending request message to the rest of the sites. So S1 and S2 are making request for the critical section, and that is why they are sending the request message respectively to the other sites. Now the timestamp of the requests are 2 1 and 1 2. Now in this in the step number 2, since S2 has received a reply message from S3 as well as from S1, so it means S2 has received the reply message from all those sites which to whom they have to whom this S2 has already requested. So it will enter into its critical section. Now, whenever it enters into its critical section, and once it enters into the critical section, whatever number of critical section it has to execute, it will execute, and then S2 will release. S2 exits the critical section and sends a reply message to S1. Um, um, uh, to the S1. Okay. Now S3 has already replied because S3 was not in the critical section, since S2 was critical section. So what it has done, it has before the time when it was in critical section, it has not sent the reply message to S1. But once it is coming out of its critical section, it will send a reply message to S1. So this indicates that there is no need of release message. It is the reply message which will work effectively for this site S1 to go into its critical section. So just by reducing the number of messages, so this is working very similarly. Ricart-Agrawala algorithm is working very similarly to the Lampport's algorithm, with one change only, that instead of request, reply, and release message, reply and release message are merged together. And whenever a site is going to be in its critical section, and whenever it is exiting the critical section, and sends the request, sends the reply message in the form of a request which it has received, that will function as a release, and that will allow the S1 to go into its critical section. So this is about the Ricart-Agrawala algorithm. Now the next algorithm is MACWAS algorithm, which works differently from Lampport's as well as Ricart-Agrawala algorithm. Now, the concept related to the MACWAS algorithm, because it is not going into the general trend or whatever the previous two algorithm was working, but the concept which is conceived by MACWAS algorithm is that, first of all, a site who does not request, site is not going to request permission from the every other sites, as it is done in the Lampport's as well as the Ricart-Agrawala algorithm. But it is going to it is going to ask the request permission only from the subset of the sites, meaning thereby it is not necessary in MACWAS algorithm, it is not necessary to send the message to all, but what is being done, all the sites are grouped together in the form of a domain. All the sites are grouped together, and the group is being framed in such a manner that there must be at least one site which will be common, meaning thereby if we are making two groups of two sites, two groups of three sites, two groups of four sites, whatever we are working with, at least there will be at least one site which will be common, meaning thereby whenever we are making subsets, and whenever we are going to take the intersection of two subsets, two groups, there must be that must not be nil. There must be at least one site which should be available. So for that we try to maintain a group set in the form of a Ri and Rj, and those sites which will be available in the group we will be framing the number of elements in that particular group. So whenever a site wants to go into its critical section, it is not necessary for that site to to request all the other sites, but it will make a request to in its group only. So a site requesting the permission, it will be done only in the subsets of the site, and how these subsets are made, it can be made in the form of a 2, it can be made in the form of a 3, and basically those sites will be the adjacent nodes. Those who are adjacent, they are made in the form of a group. Now, if a site SI request set of sites SI and SJ, suppose there are two sets SI and SJ, and it will be RI RJ, such that RI and RJ will have at least, this is the site name SI and SJ. SI is maintaining its vector in the form of a RI, SJ is maintaining the vector in the form of a RJ, and what RI and RJ contains, those sites which belongs to the group of SI, and SJ those sites which belongs to the group RJ. And RI and RJ are such that RI and RJ will have at least one common site, that is SK. So SK will be a mediator which is going to resolve the conflicts, if any, if it is arises in between RI and RJ. So a site who wants to go into its critical section, it will send one message at a time. So a site can send only one. Once it is sending the message, it will be sending the message into the group, and whenever a site is going to reply, a site can send reply only one reply message at a time. That is, a site can send a reply message only after receiving a request message from the previous reply message, after receiving a release message from the previous reply message. Meaning thereby, if a site is requesting to the other site and the other site is already in its critical section, so it will not giving any kind of reply. So it will be giving reply only after it has received the release message from the previous reply message. So therefore, a site SI is going to be logged all sites in the RI in the exclusive mode before executing its critical section. So this is the concept which is given by the MACWAS. Now, what is the request set rules for the MACWAS algorithm? Set RI and RJ have at least one common site, as explained earlier. SI is always in the RI, it is also true. Meaning thereby, whenever you are maintaining RI of a site SI, so this SI must be present in RI. Suppose we have P1, P2, and P3. So we have to maintain SI, S1, S2, and S3. So R1 will have at least S1. Similarly, R2 will have at least S2, and R3 will have at least S3. Besides, R1 is having S1, it may have S2. Besides, R2 is having S2, it may have S1. Besides, R3 is having S3, it may have S1 or S2. So there must be SI which should be available in the RI, means S1 must be in R1, S2 must be in R2, and like that. Now the cardinality means the number of the sites which will be available in RI will be represented by the cardinality of I, and that is the number of the sites in RI. And it may be 2, it may be 3, it depends the number of the sites which are available in the, it depends that how we are framing a group. Now any site SI which has a number of RIs, which has k number of RIs, then n is equal to k into k minus 1 plus 1, and where k is the square root. This is the number of messages which has to be sent, which has to be exchanged whenever a site is going for the in the request mode. So how the request is being done? Site SI sends a request I. I stands for the site number. So SI sends a request I to the sites in RI. Suppose करिए कि RI में उसके suppose करिए S1 है ये, और RI में यानी R1 में S1, S2 and S3 है. So S1 wants to go into its critical region. So S1 will be sending the request I message to our S2 and S3, which is available in RI. Now, the S2 and S3 will be replying depending upon the condition. It will send the reply message. SJ will send the reply message to SI if SJ has not sent a reply message to any site after it received the last release message. Whenever it has received a release message from some other site and it has not sent a reply message to the other site, then only this reply message will be giving to the SI. Otherwise, it will be queued. Whatever SI has sent in the form of a request to site SJ, it will put in the queue. Because why it will be put in the queue and it will not send the reply message? Because it has already replied some else sites and it has not received a release message from that, so it will not send the reply message. And if it has not sent a reply message, it will give the reply message to the site SI. So in this way, the requesting is being trained. Now, similarly, SI can go into its critical section only when it has requested to S1 is requested to S2 and S3. So S2 and S3 both will be giving the reply message. Then only S1 can go into its critical state. So that is what they're executing the critical state. After getting the reply from all the sites in the RI, just as I have given the example that there are in R1, suppose S1, S2, and S3. And S1 has want to go into its critical section. So S1 has given a request message to S2 and S3. S3 is free and it has not given a reply message to anybody else. S2 is also free, S3 is also free, and they have not sent any reply message. So they will reply it to S1. And when the S1 will get the reply, it will go into its critical section. Now, what happens while releasing the critical section? After a site which has gone into the critical section, it is over, the critical section is over for the site SI, it will send a release message to all the sites in the RI, meaning thereby S1 has sent the request message to S2 and S3. S2 and S3 was free and they have given the reply message to S1. S1 has gone into its critical section. Once it complete or finishes or want to exit its critical section, it will send a release message to S2 and S3. And when the sites SJ receives the release message from the site SI, it sends the reply message to the next site which are in the waiting, which are waiting in a queue, and deletes that entry from the queue. जिसको वो reply कर देगा, to whom they have replied, it will delete the entry from its request set. And if the queue is empty, then the site updates its state to reflect that site has not sent out any kind of reply message. So that is how this MACWAS algorithm used to work. Now, as far as the performance is concerned, there is a synchronization delay of 2t because there are two kinds of exchange is being done. So it is 2t and 3 times of the square root of n, one each for request, reply, and release message. It means the messages are required 3 under root n. But we have a certain problem which is related with the MACWAS problem, and that is the deadlock problem. And this deadlock problem can be explained in a very message delivery are not ordered in this particular case, as you know. And now how it deadlock condition can occur. Suppose we have 3 concurrently requesting for the critical state. RI is the intersection of RJ. RI intersection RJ is Sij. RJ intersection RK is Sik, and RK intersection RI is Ski. So it may be possible that Sij is logged by Si, forcing Sj to wait at Sij. Sjk by Sj, forcing Sk to wait for at Sjk. So it may be possible, and due to this, the deadlock condition can occur. And if there is a deadlock condition, then it will be this algorithm will not work. So This is all about the MACWAS algorithm.